Okay, well, you're all very upstanding people for staying so late. So my name's Jez Humble. I work at Google. I've been part of a 6-year research program into how to build high-performing technology organizations run by Dr. Nicole Forsgren. She's the principal researcher. And we've gathered loads of data, over 30,000 data points at this time, over 6 years. And I'm going to tell you about some of the results, particularly as it pertains to high-performing teams, high-performing organizations. So we've used a bunch of statistics tools in order to do what we call predictive analysis. So we don't have causal analysis. We don't say one thing causes another, but we can say one thing predicts another. So that's a bit more than correlations, but it's not as good as causation. We can say we're doing predictive analysis either when we do randomized controlled experiments, which we don't do. It's almost impossible to do randomized controlled experiments when you're in the realm of software, just because software teams are complex systems and it's very difficult to have a control group. Longitudinal designed experiments where you're monitoring people over time, again, that's very expensive and hard to do. We haven't done that. What we're doing is theory-based design, where we take theories that have already been validated and we create hypotheses based on those theories and we test them with data, which is what we've done. It's survey data that we've analyzed based on hypotheses, which are based on theories that are already written about in the literature. So when I talk about something predicting or impacting something else, this is what I'm talking about. And where I don't say that, I'm talking about correlations. And correlations are great, but correlations are also misleading. There's a great website called Spurious Correlations, which has a number of excellent graphs, such as this one by Tyler Vigeland, which correlates per capita cheese consumption with the number of people who died by becoming tangled in their bed sheets. And there's lots more like that. So correlations are interesting, but they don't tell you whether one thing causes another, whether there's a third hidden variable that's causing those two things, or whether in fact they have no causal relationship whatsoever. So, with that note of warning, I'll carry on. What we found over the last 6 years, first of all, is that software delivery is a competitive advantage. And if you saw me speak this morning, there'll be about 5 minutes worth of overlap with this morning's talk. I apologize for that, but then we'll move on to completely new terrain that we haven't covered. So, firms with high-performing software delivery capabilities were twice as likely to exceed their profitability, market share, and productivity goals. So software delivery is important. It impacts commercial goals. It also impacts non-commercial goals that non-profits and government and everyone else has. So high performers are more than twice as likely to also exceed objectives related to customer satisfaction, the quality of products or services provided, the ability to achieve organization and mission goals, and a bunch of other things that organizations care about. So software delivery matters. How do we measure software delivery? Well, we found 4 valid and reliable measures that allow you to measure software delivery performance. And they're the 4 colored ones, and I'll talk about availability in just a minute. So lead time is the time from checking code into version control to having software in production. Deployment frequency is how frequently you deploy to production. Those are 2 measures of throughput or speed or tempo. Then in blue, we have measures of reliability. Change fail rate, when you push a change out, what percentage of the time do you have to remediate in some way because something went wrong? Time to restore, when something does go wrong, when there's an incident of some kind, how long does it take you to fix that and restore service? And then, those 4 metrics apply to everything. You can apply them to apps, to firmware, to anything that's software related. Last year, we also looked at availability, which only really makes sense for hosted stuff. And in that situation, availability works like the other ones. And works like the other ones means this, and this is the crucial fact. What we find is that high performers are doing really well at all of these things. There's this kind of very common misconception that people trade off speed against stability and availability, and we find that's not the case. We've reproduced these results for the last 6 years, and what we find is that when we do cluster analysis on our data, it always splits up into 3 or 4 groups, where there's a group that's doing really well, in this case an elite group that's able to deploy on demand multiple times per day, lead time for changes of less than a day, time to restore service of less than an hour, and a really low change fail rate. And then at the other end, there's a low-performing group. And exactly how well they're performing varies year to year, but 2019, we find they're deploying between once a month and once every 6 months. Their lead time for changes is between once a month and 6 months, or sorry, between 1 month and 6 months, because they're releasing code in big batches. They're doing, big batch releases. Their time to restore service is really shockingly worrying. And we think what's happening there is that, particularly in the case of security incidents, security breaches, it takes a really long time to fix everything. Even if you can kind of get the system back up and running, you've got data fixes on the back end and stuff like that. And then this high change fail rate. So we've consistently found there's an elite performing group, there's a low performing group, and then there's 1 or 2 groups in the middle who are doing better than the low performers, but not as well as the elite performers. This is true across all different sizes of companies. You find high performers in big companies of 10,000 or more, and you find low performers in small companies. I've certainly worked at, or I have friends, let's say, who've worked at startups, which would be in the low performing group, and I've worked in teams in the US federal government that were high performing groups. We also find that these results generalize across industry. You find high performers in highly regulated organizations, including financial services, telecoms, government, healthcare, and you can find low performing groups in technology. So you don't have to be a small technology startup to be a high performer. You can be in a big, highly regulated organization and be a high performer. And equally, you can be in a small startup and be a low performer too. So obviously, you want to know how to get better. We've been looking at that too. And what we find is there's a load of stuff which predicts software delivery performance. This is what we lovingly call the BFD, the big and fulsome diagram. These are all the things that predict software delivery performance. So I talked about some of these things this morning, particularly around cloud infrastructure. This afternoon, I'm going to talk about a bunch of the rest of them. And there's 4 basic categories that I want to cover. Firstly, I want to talk a little bit about continuous delivery and technical practices. Then I'm going to talk about lean management and product development practices. I'm going to spend a bunch of time talking about culture, and then autonomous teams are the 4th ingredient. So all 4 of these things predict software delivery performance. So if you want to get better, the way you do it is by implementing these groups of capabilities. So let's start with the technical practices, continuous delivery. So continuous delivery basically is about making releases boring, making production deployments things you can do at any time of day, at the push of a button. The more formal definition is that you can make any kind of changes in safely and quickly and sustainably, whether that's database changes or network changes or software changes, whatever it is, infrastructure changes. That should be a low-risk, predictable process. Who in this room has to perform deployments at evenings and weekends? Okay, like around 25% of you. So I'm going to take that as a sign of personal failure, that we wrote the continuous delivery book 9 years ago, basically so that people didn't have to deploy software at evenings and weekends anymore. That was the goal, to make sure that you could do deployments at any time, and it was a boring process. We're still not there yet. I'm sorry, that's not the case. But I think it's important not to accept that as an inevitable consequence of the software delivery process. I've been working in all kinds of organizations and gathering case studies, and we've shown that you can achieve continuous delivery in the federal government, building firmware, building apps, highly complex distributed systems. There's no, I mean, it's hard. It's really hard, but it's not impossible, and you can get there incrementally and iteratively. So don't lose hope. It's entirely possible to do it. It does require a whole bunch of stuff to be implemented, and that's what I'm talking about today. So over the years, we've discovered a whole bunch of technical practices which predict your ability to do continuous delivery. From source control practices like checking everything, including infrastructure configuration, into version control, which we used to call infrastructure as code and we now call GitOps. Continuous integration, trunk-based development instead of working on long-lived feature branches, to things like architecture, building a loosely coupled architecture, test practices such as continuous testing, which means testing throughout the software delivery lifecycle rather than in phases, test automation, database change management. This year we found something new called code maintainability, which I'll talk about in just a minute. We find these practices not only improve performance, they also reduce team burnout, reduce deployment pain, and increase quality as measured by the percentage of your time you're working on features as opposed to unplanned work or other or rework caused by things that you didn't do right the first time. So continuous delivery doesn't just make you better at software delivery, it makes your teams happier and it improves your quality as well. It also impacts culture, which is something I'll come back to later. So in the State of DevOps reports, we talked about these things in some depth. I just want to talk about code maintainability because it's a new thing that we looked at this year. When you have systems and tools that make it easy to change code maintained by other teams, to find code in the code base, to reuse other people's code, and to add, upgrade, and migrate to new versions of dependencies, that is one capability that we know predicts your ability to achieve continuous delivery. And all these capabilities have been written up. If you go to cloud.google.com/DevOps, DORA, when we were acquired by Google, basically stole that domain and put all our stuff on it. So you can go to cloud.google.com/DevOps and read about each of these capabilities in detail. Fundamentally, what continuous delivery is about is building quality in, making sure that you actually make sure that the things that you care about in your software are built in by developers rather than trying to fix those problems later. And this goes back to the early days of Lean, Deming's 14 points, which he wrote about decades ago, such as this one. And really the point is, if you want security, and people have talked about this even today, if you want security, if you want scalability, if you want reliability, you can't wave the magic DevOps wand and have the DevOps unicorns come and give that to you after dev complete. That doesn't work. Developers have to build that into the system from the beginning, which means that developers have to understand that and know about it, and we have to help developers do that right in the first place. It's very expensive or almost impossible to try and fix those things later on. And really, a lot of continuous delivery is about building feedback loops into our software delivery process to make it possible to do this. It's not that developers are dumb or that they're evil, it's that they just don't have the feedback loops that enable them to do this stuff in the first place. So those are the technical practices. We also found a set of lean management and product development practices. So the management capabilities are things like limiting work in process, having visual management, things like displays that show you how many automated tests are failing, things like that. Feedback from production and using that feedback to make business decisions, and a lightweight change approval process. And what's interesting is when we actually went and looked at the data, we thought that limiting work in process would predict software delivery performance on its own. And we found that it didn't. That was really weird. It's a slam dunk. Everyone who studies Lean knows that limiting work in process makes things better. But when we actually ran that analysis on the data, we found that that wasn't the case. What we found is you have to combine limiting work in process with visual management and feedback from production in order to have the impact on software delivery performance. So as we do our analysis, we find all these interesting things. Sometimes our assumptions are wrong and our hypotheses are disproved, and we need to go and do further analysis. So that's one of the kind of interesting tidbits that came out of this research program, is that you've got to combine some of these things to see the impact. Lightweight change approvals is something that gets a lot of pushback. What this is when you make a change, who works at a company where before you can take software changes and push them live, the release has to be approved by a change advisory board or some other team that's external to the software team? Who has that situation? About 25% of you. Okay, so in the course of our research program, we found that that doesn't work. What it does is it reduces throughput and does nothing to improve stability. So basically, it slows you down without giving you any corresponding benefit. And we did a deep dive on that this year. So if you go and download the 2019 State of DevOps report, there's a whole section on why that kind of heavyweight change approval process doesn't in fact work. What does work is when you have a lightweight change approval process, which means code review within your team, or pair programming, or other mechanisms by which people on the team check each other's code. So it's not that change approval is bad, it's that it has to be done in small batches pretty soon after the code is written by people on your team who actually understand what's going on. And you can absolutely achieve the goals of control objectives like segregation of duties that we absolutely care about in regulated organizations using a lightweight process. That's very effective, but heavyweight change approval doesn't actually work, even though it's not, it's basically not the best way to achieve that control objective. Lean product development are a set of practices that come from, they've been talked about a lot in the lean startup literature. That's things like working in small batches, where we define that as being able to complete work in a few days or less than a week. So when you build new features, you should be able to complete them and get them out in a few days. Making the flow of work visible, that's everyone in the organization being able to see work as it flows from idea to being developed to all the various stages it needs to go to get to production. Gathering and implementing customer feedback. And then one of my favorite ones, team experimentation. So team experimentation means that the people working on the software have to be able to change requirements in response to what they learn and what they know about the system. Who here works in an organization that's agile, or a team that's agile? Everyone, right? Because everyone says they're agile, right? Anyone working in a team that's like waterfall? We are doing waterfall. Okay, a couple of you, so good for you. Who works in an agile team where the developers, you have to do what's written on the story cards, and you don't get any input into that? Okay, a few of you are like, yes, shit. So yeah, that's a real thing, we're using story cards, we're having stand-ups, everyone's been to the 2-day Scrum training, and now we're taking orders from management standing up instead of sitting down. And that big backlog of requirements you can't ever complete is now prioritized and estimated in Agile, yay! But you still, why are we doing this? Just do what's written on the card. Okay. I'll take the story card and sit over here and do my work. So turns out that's not Agile. It's only Agile if you get to actually have a conversation and discuss what's being done, and as developers you get to experiment with ideas, and you get to experiment with process change as well. Process change should be something that teams have the authority to experiment with. When management sits down and says, you will follow this recipe to implement Agile and there should be no deviations, guess what? That's not Agile. So we found that team experimentation impacts software delivery performance, it drives software delivery performance, along with those other capabilities in the lean product development box. It also drives culture. Both of these things drive culture. And software delivery performance also drives lean product development. There's a virtuous circle. They're mutually reinforcing. Better software delivery performance enables more lean product development, because if you can deliver faster and more reliably, you can test ideas more quickly and get feedback more quickly. That enables you to work in small batches, which in turn drives software delivery performance. So those two things, lean product development, software delivery performance, are mutually reinforcing. And lean product development directly drives organizational performance. So again, another interesting thing about this is you can see what drives what. If you want to directly drive organizational performance, you need to implement these lean product development practices. Those will also drive software delivery performance. So seeing which way the arrows point and what they point to is a good way to reason back from the outcomes you want to achieve to the things that you can implement that will drive those outcomes. And that's why the BFD is so cool. So I've talked about culture. That culture has popped up in this box quite a lot. I want to talk a bit about culture and what I mean when I talk about culture. So culture drives software delivery performance. Culture also drives organizational performance. What do we mean by culture? There are many models of culture. The model of culture that we studied comes from a sociologist called Ron Westrom. And Westrom was studying safety outcomes in healthcare, aviation, and nuclear power. So these are domains where, when things go wrong, people die. So safety critical domains. How do we build effective safety cultures? And he came up with this typology which divides organizations up into pathological or power-oriented, bureaucratic or rule-oriented, and then generative or performance-oriented or mission-oriented is another way to think about that. And there are 6 axes on this model. Do people cooperate with each other really well? Is there high cooperation or low cooperation? How do we handle bad news? Do we train people to bring us bad news so that we can act on it quickly before problems become catastrophic? Do we ignore people who bring us bad news, or do we shoot the messenger? Are responsibilities avoided? Because I know that if I take on a responsibility and something goes wrong, I'll be fired. Are responsibilities defined narrowly so that when something goes wrong, we know whose fault it is and we can punish them? Or are risks shared because we know that we succeed and fail as a team? Is bridging between departments and between different parts of the organization encouraged or tolerated or discouraged? So an example of this is, you go into the software. I get called in sometimes to companies to help them, and I'm like, hey, can we talk to the product people? And they're like, no, we can't talk to the product people. Oh, okay. Why not? Are they in a different building? Oh, no, they're on the next floor down. We just don't want them to know that we're talking about this continuous delivery thing, because then they'll try and shut it all down. So that's an example of when bridging is discouraged, right? Because we don't trust each other. And when we don't trust each other, information doesn't flow through the organization effectively. And then 2 things that are really 2 sides of the same coin. How do we deal with failure, and how do we deal with novelty? So in an organization where failure leads to scapegoating, this thing went wrong, it was Jez's fault, let's fire Jez. Versus, this thing went wrong, yes, Jez did this thing, which we can see led to this outcome. Why did Jez do this thing? Well, how could we have got Jez better information so that he didn't make that decision? How could we have given Jez better tools so that when why am I talking about myself in the third person? It's so weird. When Jez did this thing, it caused this thing, but the tool caught it, so it didn't lead to catastrophic or cascading failure. We are all working in complex systems. And in complex systems, there's this temporal asymmetry. When you look back after an accident, it's easy to look at the causal chain of what happened and trace it back to someone. But when you're doing stuff and looking forward, it's really hard often to predict that this thing you do would trigger that thing, which was related to this other thing up here that I didn't even know about, and that leads to a weird series of cascading failures that I couldn't have predicted. Looking back, it's really easy to see how it happened. But when I'm sitting here doing my thing, it's how would I know that that happened? In complex systems, failure is inevitable. In complex systems, failure is inevitable. There will be failure. And the interesting question is not why this person did this thing, but how can we improve the system and get that person better information and better tools to prevent that happening again? Because if we fire that person, what's going to happen? We're going to replace them with someone else, and the same thing's going to happen to that person, unless we actually work to improve the system. So in organizations or teams where failure leads to scapegoating, nobody's going to try anything new. Because novelty, doing things that haven't been done before, have a higher risk of failure than things we've already tried. And we know that failure leads to scapegoating, and so we're never going to try anything new. So if you want your team to try new things, you have to create an environment where failure isn't punished. And that sounds obvious, but it's really, really hard. Google has a whole team that looks at developer productivity and how to build effective teams. They ran this quite well-known study that I'm sure a lot of you know about called Project Aristotle, where they looked at how to build effective teams at Google. And they thought it would be, hire a bunch of Stanford graduates, fire all the managers, and put all the PhDs in charge. What they found actually was that the most important factor in building effective teams was psychological safety. Did team members feel safe to take risks and be vulnerable in front of each other? That was actually the biggest factor. And what we found, we actually asked about psychological safety and these other 5 things on a survey that we did a few years ago, along with Western questions. And what we found is that these things here are the same as the first 2 things on this list. So we replicated part of Google's results as part of our research program. And it's always really nice when you can reproduce someone else's results in a study. It kind of gives it a lot more power. So we were able to reproduce this result. So we know that this culture, a high-trust, generative, performance, mission-oriented culture, directly drives software delivery performance. It drives those organizational outcomes. How do you change your culture? Well, the way you change your culture is by implementing those capabilities that we talked about. The technical capabilities, continuous delivery, the product management and lean management capabilities. Implementing those capabilities is what drives culture. So if you want to change your culture, you change how your teams do their work. And that in turn, as the BFD shows, is driven by transformational leadership. So again, the way that these kind of boxes and arrows are arranged is important. Having transformational leadership enables you to implement the practices and capabilities. Implementing those capabilities drives software delivery performance directly, and it also changes your culture. And a more performance-oriented culture in turn drives software delivery performance. So what does a high-trust culture look like? There's a company called Etsy, which in the USA provides a storefront for people making their own crafts. And until a couple of years ago, when there was a huge management change driven by the investors, it was one of the companies that was a great example, an exemplar of DevOps practices. They had an annual developer conference. And at their developer conference, they gave out an award to the engineer who'd caused the biggest production outage in the last year. This was the 3-armed sweater award. Because if you went to Etsy.com and got a 404, there was a picture of a sweater with 3 arms. So the 3-armed sweater award went to the engineer who caused the biggest outage. And this was not ironic or sarcastic. It was genuine. Thank you for finding this problem so that we were able to fix it and improve our system and get better at what you do. Here's a 3-armed sweater. Thank you very much. So you can actually, this is John Allspore on the left and Rin Daniels on the right. And you can actually go and read Rin Daniels' blog post where they talk about the problem and what happened and how they dealt with it. It's a really interesting read. I very much recommend going and looking at that. And one of the things that Rin says is that when they spotted this outage, the immediate response from everyone around was to ask, what help do you need? And they swarmed on the problem and fixed it, and then they had a blameless post-mortem and found ways to improve the system so that couldn't happen again. And then Rin gets the 3-armed sweater award at the annual developer conference. So that's what a high-performance culture looks like. And it actually goes beyond that. In high-performance culture, we're always trying to create problems so that we can find ways to improve the system, because we know it's by creating problems that we discover ways to improve the system. So Google has a disaster recovery testing exercise, a DIRT exercise we call it, every year, where there's a whole team that actually plans out scenarios like aliens invade Silicon Valley. And they do things like switching off connections between data centers, all kinds of kind of unusual and unexpected things. And the engineers have to keep the systems up and running through that exercise. It's a really big deal. It was run for a long time by Kripa Krishnan. She says, for DIRT-style events to be successful, an organization first needs to accept system and process failures as a means of learning. We design tests that require engineers from several groups who might not normally work together to interact with each other. That way, should a real large-scale disaster ever strike, these people will already have strong working relationships. So if you want to be comfortable about the possibility of failure, the best way to do that is to practice it. And it's by practicing it that you'll discover how to improve your system and get better. And then, as a bonus, when something bad does happen, you're like, oh yeah, I know what to do. I know who's on call. I know the different systems I've got to look at to find out what's gone wrong. I know who's in charge of those systems, and you're comfortable with it because you've practiced it loads of times. This year, we looked at disaster recovery testing. We asked about it explicitly. We found that only 40% of organizations perform disaster recovery testing at least annually on production infrastructure. That's a huge problem. That's something everyone should be doing, is practicing disaster recovery at least annually on their production infrastructure, if not more often. So with that in mind, some other things that directly impact culture: retrospectives, postmortems, blameless postmortems, learning exercises. Those directly impact culture. They also create a climate for learning in which learning is seen as a strategic investment rather than something that people should do in their own time. And a climate for learning also drives culture directly. Finally, I want to talk about autonomous teams. Last year, we found that when you outsource functions like testing and operations to other organizations, that drives down software delivery performance. Functional outsourcing is bad. It reduces speed and stability. We talked about change process earlier. One of the big things you can do when you're growing autonomous teams is build trust and give people the ability to speak up. And giving teams autonomy is one thing that does that. So giving teams autonomy drives software delivery performance directly. It also makes people trust each other more. That makes them feel more able to speak up. Those things directly impact culture, and culture drives software delivery performance and operational performance. What does that look like in practice? Now, I still really like this presentation from Reed Hastings of Netflix, where he talks about Netflix culture. And there's this slide that I particularly like, where he talks about highly aligned, loosely coupled teams. And this is an architectural thing. One of the things we talk about in State of DevOps is a loosely coupled architecture, but it's also an organizational thing. And Conway's law says that those two things, the systems architecture and the organizational architecture, support each other. What you want is teams that are highly aligned, where they have a clear common strategy and set of goals that are known to everyone and that everyone is working towards, and that team interactions are focused on those strategic things rather than individual tactics. But then you want teams to be loosely coupled. So you don't want them to be meeting all the time because there's these fine-grained dependencies between the work they do, which again requires cross-functional teams where everyone involved in design, delivery, operations, co-located. That's what enables you to have fine-grained interactions happen within the team and coarse-grained interactions between teams. And then post-mortems on tactics in order to increase alignment. And then crucially, trust between those different groups. So 4 things we've covered. How do you improve software delivery performance? These 4 things: continuous delivery, lean management and product development, a mission-oriented culture with psychological safety, and autonomous cross-functional teams. The only really sustainable way to do this is to have leadership support. Transformational leadership is the only way to ensure that when you try these things out, they become institutionalized. But if you don't have that, you should still go ahead and try things out. Guerrilla change management is better than no change management. So I want to end with these words from Rear Admiral Grace Hopper. If it's a good idea, go ahead and do it. It's much easier to apologize than it is to get permission. Thanks very much. We have 5 minutes for questions. Thank you. All right. All the stuff is on cloud.google.com/DevOps. Yes?
On the left side of that big chart was transformational leadership.
Yeah.
Which seems to be sort of a prerequisite to anything improving. I've found that to be exceedingly rare. Do you have any advice to us in the trenches where transformational leadership is not on the top?
Yeah, so what do you do when you don't have transformational leadership? So I wouldn't say it's a prerequisite. I say that it helps. It definitely drives those things. I think the important thing to remember about leadership is that leadership doesn't mean the executives. Anyone can be a leader. A leader is about taking ownership of things and rewarding people and supporting people and providing stimulation and inspiring people. Anyone can do that. So anyone can be a leader. And I've certainly seen in big organizations, you'll have teams where you've got a courageous manager who will kind of help teams experiment and then pretend to the rest of the organization that everything's fine, nothing to see here, right? So, I mean, every big organization I've worked in, certainly, your experience as an employee is very much driven by who you report to, rather than the organization as a whole. If you're working for someone who's a good manager and knows how to help you grow and help the team work together effectively, even if the rest of the organization is kind of a bit of a trash fire, that can be a really good experience. Equally, if you're working in like a good organization, but your manager's awful, that can be really, really miserable. So I think a big piece of this is, just working for a good reporting to someone who's a good manager. So, I mean, obviously, there's no way to control that until you get into the organization. Once you're in the organization, then you can find those people and try and work with them. I mean, there's also Martin Fowler's advice, which is change your company or change your company. But obviously, that depends on there being jobs available for you to go into as well. So that's kind of very end of the rope advice, I think. But I would say, every big organization is very heterogeneous. People ask me, like, which are the great organizations? And they're all very different inside. I can tell you that Google, there's some things that are great about Google. There's some things that are not so great about Google. And there's some things about working in the federal government that I really, really loved. So it's just about where you are in the organization, and your local experience, I think, is a much bigger deal than the overall organization. Other questions? Is there free beer or something outside? All right, well, I'll be here for a few minutes. Thanks very much for your time. Have a great evening.